One gas turbine humming beside a data center skips the grid's 5-year wait to plug in. 0 wait years. That shortcut gets the AI online fast. It also lifts the number on your household electric bill. Here's the scale nobody pictures. A single AI data center now pulls hundreds of megawatts. Some cross 1 gigawatt. That is the appetite of a small city or a whole power plant, all behind one fence. The grid was never built to add a city overnight. So each operator faces one choice: buy power from the grid and wait, or build their own plant and burn their own fuel. Guess who pays for that decision either way? You do. Start with the obvious move: just buy grid power. Option A. You file to connect your data center to the existing wires. That process has a name worth knowing. Before anyone can plug a giant new load into the shared grid, the regional operator has to study whether the wires can handle it and approve the hookup. That study and approval process is called interconnection. And it is where the years go. Why 5 years? 3 bottlenecks stack up. First, the queue. In big grid regions like PJM and MISO, thousands of projects are lined up ahead of you, each waiting its turn to be studied. Second, transmission upgrade studies. Engineers have to model whether your new draw overloads distant lines. And if it does, someone has to pay to beef them up. Third, the physical build. New substations, the yards full of transformers that step power up and down, take years to design, permit, and pour concrete for. Stack those 3, and the wait lands around 5 years before a single AI chip switches on. So what do you get for the wait? On paper, the best price. Grid electricity is cheap per unit of energy, because it's shared across millions of customers and generated at massive scale. But cheap comes with a catch. You wait years, and you don't control the timing. The grid decides when your slot opens, not you. For a company that just spent billions on chips sitting in boxes, 5 idle years is the most expensive kind of cheap. Which raises the obvious question: what if you didn't wait at all? Now the other pass. Option B, build your own power plant on site. Right on the property beside the servers, the operator installs its own gas turbine. Because that turbine sits behind the utilities meter and feeds the data center directly, engineers call it behind-the-meter generation. The power never touches the public grid, so it never waits in that queue. Here's the number that changes everything. A gas turbine can be ordered, delivered, and running in roughly 1 to 2 years. Compare that to 5 for the grid. You've skipped the line entirely. 0 wait years in the interconnection queue because you never joined it. That covers the speed. Now the cost. Speed isn't free. You pay far more upfront. The turbine, the pad, the fuel hookups, the permits, all capital out of pocket before the first watt flows. And from then on, you're the one buying natural gas and burning it month after month. That's a fuel bill the grid buyer never sees directly. What does one of these actually look like? Picture 2 flavors. An aeroderivative turbine, basically a jet engine repurposed to spin a generator instead of push a plane, is compact and starts fast, often in the tens of megawatts. A heavy frame turbine is a bigger industrial machine, slower to start but pushing well over 100 megawatts from a single unit. Line up a few and one site quietly outpowers a small town. So the trade is stark. Grid cheap fuel, long wait. On-site turbine, expensive to build but running while your rival is still standing in line. Which makes you wonder, in a race to deploy AI, which one actually wins? So put them head to head. On one side, the grid, cheap power, but a 5-year wait and reliability you share with everyone else. If the region gets tight, you're rationed alongside every other customer. On the other side, your own turbine, 0 wait years and full dispatch control. Dispatch just means you decide when the machine runs and how hard. You flip your own switch, not the utilities. For a company sprinting to deploy AI before a competitor does, that comparison isn't close. Here's the logic that decides it. The prize in AI right now is compute that's actually powered on and earning. A rival who plugs in 2 years earlier gets 2 years of a head start. Training bigger models, serving more customers, banking more revenue. Against that, the higher price per unit of grid power barely registers. Speed to power beats price per unit. That's the whole calculation in one line. When getting online first is worth billions, paying more to skip a 5-year wait is simply a good trade. But, and this is the part that follows you home. Building your own plant doesn't make the demand disappear. It relocates it. That data center now owns a brand new gas plant. Every hour it runs, it's burning fuel and putting out emissions that used to be the utilities problem and are now the data center's problem. New gas demand, new smokestack, sitting on private property. The company solved its speed problem by creating a fuel and emissions problem. And that new hunger for gas doesn't stay politely on their side of the fence. Which brings us to the question you actually came for: how does any of this touch your bill? Here's where it reaches your kitchen. And it reaches it even from the data centers that never build a turbine. The ones that do the polite thing and buy grid power. Follow the money. When a data center demanding hundreds of megawatts joins the grid, the utility has to expand to serve it. New transmission lines, upgraded substations, sometimes whole new generators. Those upgrades cost billions. And here's the mechanism that lands on you. In most regions, the utility doesn't send that entire bill to the data center. It spreads the cost across everyone connected. Every home, every shop, every apartment. That spreading has a plain name. The cost gets socialized across all ratepayers. Your monthly bill quietly absorbs a slice of a data center's power upgrade. Now add the turbine builders back in. When operators fire up their own on-site plants, they start pulling large volumes of natural gas from the same regional pipelines your utility uses to make electricity. More buyers, same pipes. Gas gets tighter and pricier. And here's the part that stings. On the grid, the price of electricity in each hour is set by the most expensive plant needed to meet demand. And very often that plant burns gas. So when gas gets more expensive, the price that sets everyone's electricity climbs with it. Follow both roads. If the data center buys grid power, upgrade costs get spread onto your bill. If it builds its own turbine, tighter gas pushes up the price that sets your bill. There is no third door where the demand shows up and your rate doesn't. Build or buy, the surge finds your meter. So here's the whole machine clicking together. The on-site gas turbine is the fastest path to power there is. 0 wait years, no queue, running while everyone else waits. That speed is real, and it's why the biggest AI players are choosing it. But fast was never the same as free. The turbine doesn't erase the cost of all that power. It shifts it. It moves the delay off the calendar and onto a fuel bill, and it stacks new demand onto the natural gas everyone shares. That's the master switch this whole thing turns on. Whether a data center builds its own plant or buys from the grid, the same demand shock ripples outward. And it doesn't stop at the fence line. It reaches your electric bill. The grid buyer spreads its upgrade costs across your neighborhood. The turbine builder tightens the gas that sets your price. 2 roads, 1 destination, your meter. So here's what to actually watch for. When your utility asks state regulators to raise rates, read the reason they give. If the filing points to load growth or names data centers as why the hike is needed, that's this exact story arriving on your doorstep in dollars. One line to carry with you. A gas turbine skips the queue, but the demand still lands on your bill. Build it or buy it, you help pay for it. If you want the next piece, why AI's hunger for power is quietly reshaping the whole energy map, follow along and we'll open that box next. This is general explanation, not financial advice.